Hello everyone. So now we will be doing a question on CPU scheduling, which comes under operating system. And we are doing a question that was asked in GATE 2017. And here in this question, you can see that we have four processes, P1, P2, P3, and P4. And the arrival time of P1, P2, P3, and P4 is 0356 millisecond respectively. And burst time is 7352 millisecond respectively. And here in this, we have to apply preemptive shortest remaining time first algorithm, scheduling algorithm, and we have to find out the average waiting time here, right? So we need to find out the average waiting time. So first of all, we have to find out the waiting time of P1, P2, P3, P4 from the Gantt chart, and then we have to find out the average time. And out of all these four options, one of the option has to be there if you have done the question correctly. Now let's start doing the question now. So now as you can see in this question, so we are given the process 1. And we know that SRTF is a preemptive algorithm, right? So if a process has taken the CPU and if a next process comes which takes less time than the process which is already then in the CPU, then the other process can preempt it and take the CPU if it is taking less time. So here as we can see that if I talk about the arrival time here, P1 has arrived at 0th millisecond and no other process is available to execute. So because P2 will arrive after 3 milliseconds, P3 will arrive at 5 and 6. So only P1 can run and it will run in the CPU for the next 3 seconds, next 3 milliseconds, because then only P2 will come and then we will decide whether the other process has to come into the CPU or not. So first P1 will come into the CPU. So we are drawing the Gantt chart for this. So initially the time is 0 and it will run for next 3 seconds, next 3 milliseconds. So now time left here is 7 minus 3, that is 4, right? Now at this location, third location, how many processes are there which can take the CPU? P1 is there as well as we have P2. Now if you talk about P1 and P2, P1 still has to run for 4 milliseconds and P2 will take 3 milliseconds. And we are applying SRTF, shortest remaining time first. So out of P1 and P2, P3 has less shortest remaining time. So now P2 will take your CPU and it is going to run for next 2 milliseconds because after that P3 will come and then we will decide which process has to take the CPU. So it will run for next 2 milliseconds. So 3 plus 2 is 5. Now how much time is left? 1. 3 minus 2 is 1. Now if at this particular point of time, how many processes are there in the memory? In the ready queue? P2 is already there. And initially we had P1 also. And we have now P3. So now you can see that P2 is left with only 1 millisecond. P1 is left with 4 millisecond. And P3 is left with 5 millisecond. So which one is least out of this? Because we have to take the process which takes the minimum remaining time to run, right? So P2 will take the CPU and it is going to run for the next 1 second. So again P2 will be there in this memory. And what is the remaining time? 1. So now 0th time will be there because it is completed now. So 5 plus 1 is 6. So now this process is no more there in the memory because it has completed its execution, right? Now at this second, 6th second, what is there in the memory? As we can see that at this second, we have, because at this second, P4 has also arrived. So we have with us P1, P3 and P4. And you can see the burst time of P1 is now 4, P3 is 5 and P4 is 2. So out of all this, P4 takes the minimum time. So this will take the CPU now. So now who is going to arrive in the next? P4 will take this CPU and it is going to run for next 2 seconds, next 2 milliseconds. 6 plus 2, that is 8. Now this has also completed its execution. So it is no more there, right? And now we at this particular second, we have only P1 and we have P3. And P1 takes how much time? P1 takes 4 millisecond and P3 takes 5 millisecond. Out of it, this is smaller. So now who will occupy the CPU? P1 will take the CPU, and the time that is left with it is 4. 8 plus 4 is now 12. And finally, we are left with P3, which take 5 milliseconds. So now P3 will take the CPU, and then 12 plus 5 is 17, right? So this is the Gantt chart for this particular processes. Now we have to find out the waiting time, right? Now let's calculate the waiting time. Now let's find out the waiting time. So waiting time of process P1. Process P1 is, now you can see from here, if I talk about the waiting time of process P1, P1 has been waiting for its turn till here, right? So this is the total time. Let me explain you in detail. Now if I talk about this time, see, as you can see, till now it has been waiting for this process. So 0 to 8 is 8 milliseconds, right? And it has arrived at 0th millisecond. So the total waiting time is 8. But during this time, this process was, P1 process was executing, right? And it executed for how many milliseconds? 3 milliseconds. This time, this process P1 was not waiting, but it was executing. So this will not be counted in your waiting time, but this is your execution time. So we will subtract this time, this slot, and how much time it is taking? 3. So 8 minus 3 is 5. So how much time it waited? 5 milliseconds. And this is the time when it was not doing anything, but it was just waiting for a turn. And how long it was waiting? 8 minus 3. So this was the waiting time of this process. Here to here it was waiting, but here it was executing. So that is now, this slot is not counted in the waiting time. Now coming to P2. Now let's understand P2. If I talk about P2, so after this is the only slot where P2 is there, and after that there is no P2. So P2 is actually continuously available from 3 to 6. So we can say that it has been waiting for the last 3 milliseconds, right? So it has been waiting at this particular time. But when did it arrive? It arrived at after 3 milliseconds. So it has been waiting for 3, but it has arrived for this 3 milliseconds. So 3 minus 3 will be 0. Let me explain you once again. See, P2 got its turn after 3 milliseconds. So it has waited for 3 milliseconds. But if you talk about the question, this P2 has arrived at 3 milliseconds only. So actually it has not waited at all. So 3 minus 3 is 0 millisecond. Now coming to P3, and let's see how much time it has waited. So now if I talk about P3, come to this part now. Here P3, it has waited for 12 milliseconds. And before that, P3 is not there. So we have 12. So it waited for 12. But when did it arrive? It arrived after 5 milliseconds. It arrived after 5 milliseconds. So that is why this time has to be subtracted. So 12 minus 5 is 7, right? And then finally we'll calculate for P4. Now coming about talking about P4. So P4 has been waiting from this interval to this interval. So how long it waited? 6 milliseconds it waited. But if you see this question numerical, it came after 6 milliseconds. So actually it did not wait at all. 6 minus 6 is 0. So this is the waiting time of P1, P2, P3 and P4. So what about the average waiting time? So average waiting time is your average waiting time of all the processes will be, we will be finding out waiting time of P1 plus waiting time of P2, then waiting time of P3 and waiting time of P4 upon how many processes are there? 4 processes are there. Now let's calculate it. It is how much? 5 plus 0 plus 7 plus 0 upon 4. So 12 by 4 is how much? 3. So it waited for, the average waiting time is 3 milliseconds when we apply SRTF. So now what will be your option? What will be the answer? Let's see. So out of A, B, C and D, we can see that our answer is 3 milliseconds. So this will be your right answer. So this was all about today's session. So stay tuned to my lectures to get more updates. Till then, take care. Thank you so much.